Good morning, guys. I am going to start the notes on section 4, chapter 5, and I start this off with watching a short video from Tyler, who's going to kind of explain to us about polyatomic ions, and then we'll go from there. So I'm going to go ahead and play this and follow along as it's going.
So what's a polyatomic ion? Well, a polyatomic ion is a group of atoms that has a charge. Here's what I mean. You probably already know that individual atoms can have a charge. They can form ions. So we can get things like Na+, Mg2+, and O2-. Polyatomic ions are what happens when more than one atom comes together and they form a big group of atoms, and then that group of atoms itself has a charge. So polyatomic ions are things like NO3, 1-, where we have one nitrogen and 3 oxygens all connected together to form a group, and that whole group has a charge of 1-. Poly means many. So here, polyatomic ions, we're talking about ions that are made up of many atoms, more than one atom. Let me show you a few examples of how this actually works. So here are two of my favorite polyatomic ions, ammonium and carbonate. Ammonium here is made up of 1 nitrogen connected to 4 hydrogens, and carbonate is 1 carbon connected to 3 oxygen atoms. Now, the atoms that are in each of these polyatomic ions, they have protons and electrons in them. So what we can do for both ammonium and carbonate is we can count up the number of protons that are in each of these atoms. If I do this for ammonium, I get 11 protons. And then if I count up the total number of electrons that are in this whole group, I get 10. So these two numbers don't balance out. I have more protons than electrons, which means that I have more positive charge. I have a net charge of 1+ because I have 1 more proton. So my net charge here is 1+, and I can write the formula for this polyatomic ion as NH4, because I have a nitrogen and 4 hydrogens, with a +1. I usually will also take the structure of this ammonium and put the whole thing in brackets and put a plus outside to indicate that this whole group of atoms together has a positive charge. I can also call this thing a cation, a polyatomic cation, because a cation is what we call ions that have a positive charge. Now, carbonate, we can do the same thing with it. We can count up the total number of protons that are in the atoms that make it up, and we can also count up the total number of electrons that are in this whole group. We get 30 protons total and 32 electrons total. So we have more electrons than protons, which means we have more negative charge. It's going to have a net negative charge, and since there are 2 more electrons, it's going to have a net charge of -2. I can write the formula for this polyatomic ion as CO3, 2-, 1 carbon, 3 oxygens, total net charge of 2-. And then I write my structure in brackets and put a 2- here to show that this whole thing has a net charge of 2-. We call this guy a cation because it has a positive charge, so we can call carbonate a polyatomic anion for negative ion. As I said before, there are a whole bunch of polyatomic ions. I have a small number of them on this list right here. A lot of times people ask me, they say, okay, if I knew that, say, nitrate was NO3, but I didn't know the charge, would it be possible for me to figure out the charge just on my own? And unfortunately, no. It's very difficult to figure out how many electrons a polyatomic ion has, and so you need that to figure out the charge. Polyatomic ions are really important for when you're writing chemical formulas of compounds, and since you need to use them a lot, they're one of the things in chemistry that you really just have to memorize. So I've made a video on that. It's called Learning Polyatomic Ions. If you need to learn these, which you probably do, you might want to check that video out. I talk about a number of strategies where that you can use to better learn these. Also, if you're interested in the actual bonding that's taking place in the atoms that make up a polyatomic ion, it's a little bit more advanced, but you might want to check out the video called How Are Polyatomic Ions Made, where I talk about the covalent and ionic bonding and the sharing of electrons that takes place as these polyatomic ions form. So anyway, that's what polyatomic ions are. They are groups of atoms that come together and have either more electrons than protons or more protons than electrons, and because of that, this whole group of atoms together has a charge.
Okay, so then I would go on, I would ask your classmates to write down what we learned from the video from above. So as that video is playing, they hopefully would be writing down stuff. And I mean, what I see mostly in previous years is that, yes, they're a group of
Let's talk
atoms.
about bonding
Oh,
in
sorry.
polyatomic ions and compounds that have polyatomic ions.
Okay, so what they would say is that, yeah, it's a lot of kids say it's a group of atoms. So, okay, it's a group of atoms. And then one of the other things people might say is normally like, yes, there's more protons or more electrons, and that's how that group of atoms has that charge on it. One of the big things that sticks out to kids is that there's no easy way to do it. Like, you just need to memorize these things. So that's another one. They might talk about how they were bonded, stuff like that. But that's kind of what we get out of that video. It's just kind of a quick summary of what we're going to be doing. So whatever you wrote down there. All right, so this next thing says the list of polyatomic ions I am handing out to you, you can have out for tests. Now, normal school years without COVID, you would come in for a test and you could have this in your periodic table out. This is what it looks like. It's this right here. I'm going to post it on Google Classroom. I will have it under the important information, but I will also post it with your worksheet. So it'll be in one of those two spots. So if you ever just need to get it, you can't find it or you can't print it off and you ever just need it, it's in that important information spot from the beginning of the school year. It has this, your periodic table. I believe it had like the semester project stuff there. So anyways, this is all the polyatomic ions. That's a lot to memorize. And if you take chemistry in college, I never had to memorize them, but I have seen where I've had previous students say they had to memorize these. So I will not make you do that. We start using them enough that oftentimes students start to remember them anyway, just kind of like I have students in here that I can say what's the charge of sulfur, and right now they could probably tell me. I didn't make you memorize it, but you've used it enough now and seen it enough that you know. So anyways, that is the list right there. And I'll be referring back to that through these notes. All right, so it says, naming compounds with polyatomic ions. The positive ion is always named first. That's nothing new to us. That's what we've been doing. So most of your polyatomic ions, if you notice, most of them are negative. If you look through here, we've got a lot of negative numbers here. There is a positive right here for the NH4, this one right here. But for the most part, they are negative numbers. All right. So we're going to name the positive ion first, and then we're going to name the polyatomic ion is named second. That's because that's what happens in most cases other than ammonia, which is one of our few positive ones. So an example here, we have NaNO3. So here it's going to be really important that we are doing capitals and lower cases. If I were to write this as NaNO3, it looks like there's an element, and then I need to remember, I need to start knowing that this NO3 comes as a package deal. And then, or if I do this, if I am like doing this, or if I'm doing anything outside of that right there, like it can start to mess me up. All right, so I see this, and as soon as I see capital lowercase, I'm like, there is my element. And Na is sodium. Now I see this, and this is not what I'm used to seeing in section 2 or section 3. So right away I'm like, that must be one of these polyatomic ions that has many atoms in it, right? It has 1 nitrogen and 3 oxygens. So I'm going to go back to the sheet, and like I said, you'll just start to know this. Here is NO3, and it is nitrate. So I'm just going to name it like it looks. This is sodium nitrate. Now the big thing that we learned in the previous section, in section 3, is that do I know the charge of this? Because if I don't, then it's probably coming from a transition metal and I have to figure it out. and then I have to do a Roman numeral, but sodium is in column 1, and I know that's always going to be a plus 1, a positive 1 charge, so I don't need to do that. Just name it, sodium nitrate. All right, so which do you think is the correct formula and why? So if you look at this, I've got 2 different ways of writing this, and this is, I see both of these. One of them is correct, but I do see the incorrect one written quite a bit, so I want to make sure that I really hit on this. So which one is correct? If you're looking at this, it is going to be the first one. All right, if I have more than one NO3, or in this case I have a PO4, it's telling you, this way is telling you that this is what you have. Okay, you have 2 phosphates, that is what PO4 is. This over here, and it's also telling you, it's also telling you that you have 3 calciums. Now over here, yes, it's telling you you have 3 calciums, but then it's telling you, okay, you have 1 phosphorus, and it's telling you you have 42 oxygens. So I would have to draw 42 oxygens out. That is not the correct way to do this. Make sure you are putting parentheses around these polyatomic ions when you are crisscrossing charges. All right, so here's what happened here. I have calcium, which is a +2, and I have phosphate, which is a -3. So when I took these and crossed them, I need to put that parenthesis there, okay? All right, so that's really important, and I will try to, if you don't do it the first few times, I'll just kind of correct you, but then eventually I'm going to be like, hey, you guys have to start doing this or it's going to be wrong. All right, so the learning check, let's look at it. Select the correct formula for each. So I have aluminum nitrate. So if you're not sure yet, if you're not comfortable with these, you're going to come over here and you're going to look for nitrate. And it is NO3, and it's a -1. NO3 with a -1. So I know that is a -1. And then I've got aluminum, which I'm just going to use my periodic table. It is a +3. So you still are going to crisscross these, but remember when I crisscross this 3, I have to put it in parentheses. All right, so your correct answer is C. On B, you have copper 2 nitrate. Well, nitrate we just used. So now this one, copper, remember this Roman numeral is not telling us how many, it's telling us a charge. So that's a +2. I just looked up nitrate. It told me it was a -1. So crisscross these charges, and you are going to have Cu, NO3, and that NO3's got to be in parentheses with a 2 on the outside. Right, I don't want 32 oxygens. All right, on C, I have iron 3, which means it has a +3 charge, and hydroxide. So I'm going to go back to this. I'm going to look and try to find hydroxide. Oh, it's not, there we go. If you look on here and you're looking for hydroxide, it's OH. Oh, I can't find it here on this thing. Oh, it's right here. OH. Hydroxide, it's OH -1. So I've got OH -1. So I'm still going to crisscross, so that 3 goes to that OH. All right, so it is going to be C. And then lastly, I have tin 4. So it means that charge is +4, and hydroxide again. So it's OH -1. I'm going to crisscross. So that 4 goes to the hydroxide, and it's OH. Now, one really easy way to figure out, hey, am I supposed to be looking at that polyatomic sheet? Look at this. So far, everything we have done has ended in IDE. This is ATE. Now, this one is weird, but it's hydroxide, so it's telling you basically that's hydrogen and oxygen. But everything, most everything on this sheet, like look at the endings here, ATE, 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 ATE. Or another ATE, ITE, ITE. So it's normally ATE or ITE. There's very few, as you're looking through here, you can see that. There are a few that will end in IDE. Those we're just going to have to know. There's no easy way around that. You're just going to have to get used to them. But for the most part, you're going to know. As soon as you see that ending is different, you're going to know it's coming off of this sheet. All right. Let's do the learning check. Match each formula with the correct name. So we have magnesium on all three of these, but then I have a sulfur, then I have SO3, and I have SO4. This right here is what we have been doing. This is what we did in section 2 and section 3. So I have magnesium and sulfur, so it's sulfide. I'm always going to end it with an IDE, right? So this one is number 3. Now SO3, I'm going to go back to the sheet, and I'm going to find SO3 is right here. It is sulfite. So I have magnesium sulfite, which leaves us with SO4. If you were to go look at that sheet, that is sulfate, so it is magnesium sulfate. All right. Let's come down here to the end here. Okay, formulas are written the same as they were before with the positive ions first and the negative second. The charges still have to equal 0. So everything we have been doing before, it still applies here. So if I'm writing the formula, I'm going to look at, I've got potassium, which is a K. It's a +1. And I have bromate. Well, as soon as I see this ATE, I'm like, all right, it must be coming from this paper here. So now I'm going to look for bromate, which is right here. So it is BrO3, and it is a -2. So BrO3, -2. Now I still need these things to equal 0. So if I have a -2 charge, I need another potassium. Now that gives me a charge of +2 and -2. All right, so when you write this thing out, I'm just going to write it right here. A would be K2BrO3. Now notice I don't put parentheses around it because I don't have to put that 1 there. I mean, if you want to, you could do that, or you could put a 1 there. You don't have to though. This is how you will see me write it. Okay, that's how I will write it. That's how you'll see it on worksheets and different things like that. All right, let's look at B. I have calcium, which is Ca, and it's a +2, and carbonate. If you look back here at carbonate, see, where is it? Carbonate right here, CO3, -2. I've got CO3, then -2. If you look, these things are already canceled out. You could crisscross and you get Ca2, CO3 in parentheses with the 2, but I would be like, simplify that. Make sure that is simplified. So B is just CaCO3. We want to simplify it. All right, C, we have sodium phosphate. So sodium is Na, it's a +1. We're getting that from the periodic table. Phosphate, if you look at this right here, phosphate is PO4, and it is a -3. So PO4, -3. So if I crisscross these numbers, it's going to be Na3, PO4. The last one is iron 3. That is telling me that iron has a +3 charge, oxide. Guys, this is where it can get tricky because all of a sudden I throw in an oxide and I see IDE. It's not hydroxide. Hydroxide is hydrogen and oxygen, and it would be on that special sheet. This is just oxide. This is just pure oxygen, so -2. So this is just like what we've been doing. And this is where I can see kids struggle sometimes. They do fine with this as we're doing the notes, and then I throw one in from before, and they're like, whoa, wait a minute. So really try to pay attention to that. It will be a lot of practice. We'll do a lot of practice this week doing all the different kinds we've learned about. All right. The last one here, E at the top here, is iron 2 nitrite. So I'm going to do Fe. It is a +2. That's what that Roman numeral is telling me. And then I'm going to look for nitrite on here. So if you look here, nitrite is, it is NO2 with a -1. So NO2, -1. So crisscross these charges. We need them to equal 0. And this is Fe. Now, anytime I have to crisscross a charge to one of these polyatomics, I have to put it in parentheses. And there we go. Fe NO2 and you have 2 of those nitrates. Okay, I don't want to say that I have 1 nitrogen and 22 oxygens, I have 2 nitrates. Okay, so let's see here. Rules for naming ionic compounds. There's a flow chart here that I posted. So if you're really struggling and you want to look at this, you can. There's a flow chart, there's rules. So we have the rules for all the ionic compounds. We have just 2 elements, which is what we've done through section 3. Then I have more than 2 elements, which is what we did today. So that's what you would look at here. So that would be like NO3, SO4, CO3. You can see up here for the 2 elements, just sodium, oxygen, iron, sulfur. That's what we've been doing. The naming procedure. So if that helps you and you want to look at that, you can. This flow chart is really kind of nice. Let's see here. This is helping you figure out if you're going to use the ite or ate. Not too worried about that. If it's a metal, you're just going to use the name. Okay, guys, this flow chart might be a little bit complicated. If it's a metal, just use name. Now the non-metal side, though, it's going to end in IDE unless it's a polyatomic ion. So maybe that flow chart is a little too much. I could have done that a lot. I could have simplified that a lot easier. All right, let's do these last few learning checks, and we'll end it there. All right, so we have name the following compounds. So I know Ca is calcium. Now I have another capital, so this tells me that this is something new. Now PO4, if you look on this sheet, it is PO4 is phosphate right here. So it's just calcium phosphate. So that what I keep, the kicker here is that obviously, like, I know off the top of my head which ones I don't know the charges for. This is something that kids will struggle with, and it takes them a little bit and just takes some practice, which, like I said, you'll get plenty of. So B is an example of this. I have FeBr3. Now that is iron bromide. Now I know to leave myself a space there because right away I know that, hey, I can't look on the periodic table and find iron's charge. So I need to figure it out. So I keep drawing this out, especially for the kids that struggle with trying to figure out what this is. I have FeBr3. Now I don't know iron, but I do know bromine. So that is a total of a -3 charge, which means iron has to be a +3. Okay, so this is iron 3 bromide. Then I go back to C, and it's aluminum and sulfur. And off the top of my head, I know those charges. They're on our periodic table. So I'm just going to name it like it looks. Aluminum sulfide. Okay, if I didn't know aluminum's charge, I would have to figure it out. Here's one, manganese. I don't know the charge of. If you look on your periodic table, manganese is in the middle in those transition metals. So I know it's going to be manganese. So I'm going to leave myself a space here for the Roman numeral. NO2, I'm going to have to look on here. NO2 is nitrite. So manganese nitrite. And now I've got to figure out what is this. So this is a -1, but there are 2 of them. So altogether it's a -2 charge, which means my manganese has to be a +2 charge. So it is manganese 2 nitrite. All right, and then E, lastly, I've got sodium. Now this lowercase letter tells me that's the end of that element, and now I have HCO3. So I'm going to look on here for HCO3, and it is right here. Now you can say hydrogen carbonate. I will use bicarbonate. It's just easier, one word. That's what I always use. You can use either one. So I'm going to call this sodium bicarbonate. All right. The last learning check here. We're going to write the formulas for the following. So A, I have calcium, which is a +2. Do this. And I have nitrate, so NO3. Now, once again, I'll go back to this so you can see nitrate right here. It's NO3 and it has a -1 charge. -1 charge. Now I'm just going to crisscross like I've been doing. So this is CaNO3, 2. is iron 2. That Roman numeral 2 tells me it's a +2. Hydroxide is OH. It's on your cheat sheet here. It's a -1. You can look at that and see. So I'm going to crisscross. So this is going to be FeOH2. Now I'm making sure to use those parentheses. C, aluminum carbonate. So I know aluminum, and I can look at my periodic table and know that's a +3. Carbonate, if you look at your cheat sheet down here, is a CO3 -2. Okay, -2, so I'm going to crisscross these. This 2 will go to the aluminum, so Al2, this 3 will go to that carbonate, but I have to put it in parentheses. All right. D, I've got copper 2, Cu +2, hypobromite. That is one I do not see a lot on here, but it is right here. It is Bro with a -1. So I'm going to crisscross these. This is going to equal Cu, Bro, and parentheses with a 2. All right, and then finally, E, last one, we have lithium phosphate. I have lithium is a +1 on the periodic table. Phosphate you're going to find on that sheet is PO4 with a -3. If you go look it up, it'll be there. And this will equal, when I crisscross, Li3PO4. And that is it. So it's really, we're doing the same thing we've been doing, but yeah, it looks a little crazier. We got to remember the parentheses. There's just a few more letters involved on these, okay? You're acting like one comes as a package deal, or it really does. All right, if there is anything you need, any help at all, let me know. And the worksheet will be assigned for the next day, and let me know if you need anything with that. It will be participation. Have a great rest of your day. Bye.